Okay, and welcome back. We're doing some two-step equations today. So I have the first example right up here on the glass, and two-step equations means there's two transformations we can make to the equation to get our solution. So we'll start with an easy one. Negative 9x plus 1 equals negative 81. So remember, what we want to do is isolate the variable term, okay? We want to attack the variable. So I'm going to do that by first getting rid of this minus 1. So on the left-hand side, let's get rid of that negative 1. So the only thing remaining is negative 9x. And that's going to be negative 80 minus 1, or negative 81. So the next thing we want to do is get the x by itself, and x is being multiplied by 9. So we undo multiplication with division because they are inverse operators. And whatever we do on the left-hand side, we have to do on the right-hand side. So that gets rid of my negative 9 on the left. So now I have x equals. But we need to also do the same thing on the right-hand side. So negative divided by negative is positive. So negative 81 divided by negative 9 gives us a positive 9. Now, one of the things that your teacher may have you do is circle the answers or put an X around them, or somehow indicate that that is my solution. The other thing you may have to do, depending on which level you're at, is you may end up going back up here and showing that your solution works. So we're going to substitute, not a negative, a positive 9 in place of our equation. Oops, that's not negative 81, that's a negative 80. So when we do this, we're asking ourselves, does the left-hand side equal the right-hand side? And the answer here is, I think it does. That was a negative 9. I was thinking, no, it doesn't. But we had a negative 9. That's my mistake. So that would make me a negative 81 plus 1. Is that indeed equal to negative 80? So when we subtract the 1 on both sides, or just add these two together, we end up with a negative 80 on the left-hand side, and it does indeed equal negative 80 on the right-hand side. So sometimes you won't be doing this. You'll just be stopping when you get to here if you're pretty confident in your skills. So let's move on to the next one. All right, so here's our second example. Sometimes when we see fractions, we kind of get nervous about dealing with fractions. But the goal is still the same. We want to get this variable term all by itself. So we're going to start by getting rid of this 2. So I get rid of a 2 by subtracting 2 on each side. So that gives me the equivalent equation, negative 4 equals v over 4. So there's our first step. Our second step now, if v is being divided by 4, to undo that, we're going to have to multiply by 4. And what we do on the right-hand side, we do over here on the left-hand side. So that gives us a solution that 4 divided by 4 is 1. So v is equal to negative 1. So if I went back up here to the original equation and substituted a negative 16, let me indicate my solution here, we would find out that the left-hand side equals the right-hand side. So there's one that involves fractions. The third one I'll give you also involves fractions, but it's a little bit different. So let's look at that. Here's another fraction, okay? It's r plus 9 in the numerator and a 3 in the denominator. But if I want to get at this r and I'm dividing by 3 on both sides, what do I have to do? Multiply by 3 is the correct answer, yes. So when I multiply both sides by 3, that leaves us with r plus 9 equals, does it equal 8? No. We have to do the same thing to the right-hand side that we did to the left-hand side, which is multiply by 3. So I have r plus 9 is equal to 24. So the last thing we do is get rid of this positive 9 by undoing it with a minus 9. So those go away, and we're just left with r. So r is equal to 24 minus 9, which is 15. So I'll put a circle around this answer. So r is equal to 15. So it is kind of a fraction because we have to multiply on both sides. Then we're back into subtracting by the same thing on each side.